All right, so in this lesson, what we're going to do is we're going to walk through a notebook on how to actually use the clip model that we talked about in the slides. So the clip model, if you remember, is a dual encoder. That means it processes text and images separately. There's a model for processing text. There's a model for processing images, right? And so we're going to see what that's like. So I'm importing the clip processor and clip model from the transformers library. I've already loaded them in just to save on time, but you should see a logged output like this. So I'm loading in this processor here. I want to print out what is actually in this processor. So the clip processor comes with an image. The clip processor has an image processor right here that is going to process an image. Remember, the clip has a text encoder and an image encoder. The image encoder first has to process this image and get it into the appropriate height and width, as we see right here, do some cropping or do some other processing, right? And then it also has a text processor, which we don't really call it a text processor, we call it a tokenizer. So it has this tokenizer here that's going to take in the text and create the tokens that we saw in a previous lesson. This tokenizer will tokenize text differently than the one that we saw on the mini LM, but nonetheless, it still tokenizes text. So the image processor is going to process the image, crop it down, rescale it, resize it, convert it to RGB, all these different things right here, normalize the pixels. The text encoder, the text processor is just a tokenizer. It's going to take in the text and then it's going to tokenize it according to these rules or this metadata, and it's going to use the clip tokenizer fast. And so if we look at the model, right? So the model is broken up into a text model and a vision model. And so that's the dual encoder portion of it. We have this text model, which is a text transformer. And it's just, it looks like, from what I'm understand, from what I look at it, it looks like your typical transformer that you would see in a typical encoder transformer model, right? So it has an encoder, but it doesn't have a decoder, and it's an embedding model. So it's going to take in text, it's going to tokenize it, pass it through the encoder, and then it's going to do a final layer norm. And so the vision, it also has a separate vision model here, and this is the vision transformer, which is also an encoder, and it has a projection layer and for the visual, and then a text projection layer. And so these are both embedding models. They take as input text and image separately and produce in text embeddings and image embeddings separately, with two separate models and two separate processors for each data type. So I'm going to load in this image. This is an image of a cat. You can see here, these are two cats. Very cutely, you know, with two remotes, two cats. Just looks like they're just sleeping on a couch. And so we're going to pass that into the clip model, but we're going to send in two pieces of text. We're going to send in these two pieces of text. The first piece of text has a photo of a cat. The second piece of text has a photo of a dog, which we know it's not. And then we're going to send in that one image. And so we know that these two pieces of text are going to be passed through the text model, and then the image is going to be passed through the image model. So we should be expecting two embeddings being produced on the text model, right? One embedding for the photo of a cat and one embedding of the photo of a dog, and then one embedding on the image model for the image. And we're going to see which one this image embedding is more similar to an embedding space, and we're hoping that it's more similar to this one. So I'm going to process that. You get the tokenizer mask here, the tokenizer information, you get the tokens and the intention mask. You also get pixel values outputted by the processor. So it outputs input IDs, which is the tokenization of the text, and then the pixel values, which is the processed image that was sent through. And now we're going to pass these through the model. It's going to take just a second. And then we get all this information. And I'm just really going to focus on the text embeddings and the image embeddings. And so you can see here the image embeddings, which was the first one that was printed out, it's just one embedding of 768 dimensions. And that makes sense because we're only sending in one image. The text embeddings has two embeddings of 768 dimensions each. And that makes sense because we send in 2 pieces of text, photo of a cat, photo of a dog. And now what I'm going to do here, this code, all it does is calculate the, I said cosine similarity. This is the dot product similarity. I don't want to have any confusion here. All right, and so it's going to calculate the dot product similarity between that image embedding and both text pieces of text sent in. And so we got 0.189 for the first piece of text and a 0.117 for the second piece of text. Remember, the first piece of text was a photo of a cat. The second piece of text was a photo of a dog. And so it's saying that the image embedding has a higher similarity to the piece of text that says photo of a cat. And that's exactly what we want, right? And so we can convert these to probabilities just by passing them into, just by doing a softmax. And you can see that this model has a 99% confidence on the fact that this is a photo of a cat, right? So these are just like, these are just similarities. But if we take the logits and we calculate the probability of which one it thinks it's more similar to, it's saying it's a 99% 0.99 probability that this image embedding is more similar to the first piece of text we passed in, a photo of a cat. And so this is how you can use the clip model to compare the similarity between text and image. And you can also use this in a database of images and text, where you can literally, let's just imagine you had a database of several images like this, and you could query it. You could send in text queries and retrieve images. And it's a lot like how Google's image retrieval works whenever you go and search for images. And definitely play around with this. You can play around with other multimodal models as well. Clip is a good one. It was created by OpenAI. And yeah, this is how you can work with multimodal models in using the Transformers library.